Assalamualaikum and hi everyone. In this lecture video, we are going to discuss two topics. The first one will be 4.1 antiderivative and the second topic will be 4.2 indefinite integral. So the process of getting back the function fx from the derivative f prime x is known as integration. Before this, in the previous chapter, you are given fx and then you want to find f prime x. But in this chapter, you are given f prime x and you want to get back the fx. So the process is the other way around of what you have done in previous chapter differentiation. So please correct this one, because this one's supposed to be the process of getting back the function fx from the derivative f prime x is known as integration, because this is process, and the result of getting back the function fx from the derivative f prime x is known as antiderivative. And below here you have the formal definition for antiderivative, but you will understand this definition when we go with examples later. So what you have done in chapter 2 and chapter 3, you are given y equals to fx, and then you differentiate with respect to x, and the result is dy dx or f prime x. But in this chapter, you are given dy dx or f prime x, and you want to get the function fx or the y. So suppose we have a function fx equals to 2x cubed, and then you want to find a function capital Fx such that f prime x is equals to 2x cubed. Okay, based on the previous definition that we have here, this one, we know that f prime x is actually fx. Okay? F prime x equals to fx. And in order to find capital F, we want to find capital Fx, then what you have to do is you need to perform an integration, or you want to find the antiderivative of fx or capital F prime x. So in this case, when we want to find the solution, the solutions are not unique. Okay. Actually, we have many solutions, because if you can see here, we can say that capital Fx is equals to 1 over 2 times x power of 4. We can also say that capital Fx is equals to 1 over 2 x power of 4 plus 5. Or we can also say that capital Fx is equals to 1 over 2 x power of 4 minus 3. And actually you can have any constant here. Okay. For this one we have plus 0. For the second one we have plus 5. And for the third one we have minus 3. And actually you can have any constant, because when we perform the integration, later we'll see the formula in order to find the antiderivative. So what we will do is, when you have this, when you have this capital Fx, if you find the f prime x, you'll get it is 2x cubed. This one also you will get capital F prime x is equals to 2x cubed. This one also, and whatever the constant, you still get capital F prime x is equal to 2x cubed. Therefore, when we write the antiderivative or the result of the integration, we want one general answer. So what we will do for the final answer, capital Fx, we will write like this, where we have capital Fx is equals to 1 over 2 x power of 4 plus c. This c, usually we write it a capital case, but it doesn't matter, it's just a symbol. Okay, so this is an example where we write the result of the integration, okay, where in this case in this case we have here this is the antiderivative, and the process of finding this antiderivative is called as integration, and we use the integral symbol, where this is actually derived from the stretched capital letter S, stands for summation. Okay? It is based on the concept of summation. Okay, let us look the next topic, indefinite integral. So what is indefinite integral? The function integration fx dx equals to capital Fx plus c, where c is an arbitrary constant, means that f is an antiderivative of f. It is called the indefinite integral of f and satisfied the condition that f prime x is equals to fx for all x in the domain of f. So the notation that we have in indefinite integral, when you write this integral symbol, we don't have the limits. If you have limit here, the lower limit and the upper limit, then we call that as definite integral. But without the limits, then we call it as indefinite integral. So these are the basic integral formula for some general functions. We have more formula from your formula book. You may refer to page 22, 23, and also I guess 24 as well. You can check later. And some of the formula will not be using for your syllabus. For your syllabus, we just concentrate on certain formulas. So what are the formulas that will be asked in the assessment? You have to refer to the exercises later. So if example or formula that we are not going to use is such as the sine hyperbolic function, cos hyperbolic function, and so on. Okay, so you'll know what are the formula that we are going to use in the assessment based on the exercises and examples that we are going to discuss here. Okay, so these are the basic integral formula that we will be using for this chapter. Okay, let us look how we want to evaluate the following indefinite integral. Okay, so evaluate the following indefinite integral. Question A, we have negative 2 dx. A. For question A, we have negative 2 dx, where negative 2, if you see, for question A, integration negative 2 dx. And if you see from the list of the formula given, negative 2 is actually a constant. So we're going to use this formula. Because integration k dx, where k is a constant, you'll get the result is kx plus c. So in this case, our k is equal to negative 2. Therefore, it is equal to, integration negative 2 dx, it is equal to negative 2x plus c. For question B, we have integration x power of 5 dx. Okay, based on the formula that we have in the provided table of integration, x power of 5 is actually in the form of x power of 5 is in the form of integration x power of 5 is in the form of integration x power of n, where in this case we have n, it is equal to 5. Therefore, the formula, this will result this equal to x power of 5 n plus 1, where n is 5, so 5 plus 1 over n plus 1, so over 5 plus 1 plus c, where this is equal to x power of 6 over 6 plus c. Next, question C. For question C, we want to integrate 1 over x cubed. 1 over x cubed with respect to x. If you look at the formula given in the table of integration, we don't really have the formula in the form of 1 over x power of something. The only choice that we have is this power rule, this one, where we'll try to rewrite first integration 1 over x cubed so that it will be in this form. So we will rewrite negative integration 1 over x cubed as integration x power of negative 3 dx. So in this case, now we have based on this formula. Okay, so we will use that formula. So integration x power, it's supposed to be, this is equals to x power of negative 3 plus 1, where our n is negative 3, so n plus 1 is negative 3 plus 1 over n plus 1, so over negative 3 plus 1 plus c. Okay, don't forget to put plus c, if not then your final answer will be wrong, because we need that constant. Okay, where this is equals to negative x power of negative 2 over 2 plus c. And usually when we write our final answer, we don't want negative power, so we will rewrite this answer to, it is equals to negative 1 over 2x squared plus c. So this is the answer for question C. Okay, next we want to find the integration 3 times root x dx. Okay, if you see from the table of integration, we don't have in the form of root sign, so we have no choice. We have to rewrite this in the form of one of these given formula. So this is equal to 3. We can factor out the constant 3. So 3 times square root x. Square root x can be rewritten as x power of 1 over 2 dx. Okay, we not yet integrate it. We just rewrite the original question, the original integral to in the form in another form. So this is equal to, okay, the constant remain there. We don't do anything with the constant. And then x power of 1 over 2. This is actually x power of n, okay, based on this formula. So here we have x times with 3 times with x power of 1 over 2 plus 1 over 1 over 2 plus 1 plus c. So whenever we start write the antiderivative, then we straight away have plus c at the end of your answer. So this is equal to 3 x power of 1 over 2 plus 1 is 3 over 2 over 3 over 2 plus c. And if you see here, we have fraction in fraction. 3 over 2 is a fraction, and then it is in another fraction. Okay, so we want to rewrite this so that we just have a single fraction. And in order to do that, we know that this is equals to 3 times 2 over 3 x power of 3 over 2 plus c, where this is equals to, in this case we can cancel out 3, so the result will be 2 times x power of 3 over 2 plus c. Next question, E. E, we have integration 8 e power of x dx. So what we will have here, if you see from the table of integration, the formula involving exponent, the only formula that we have in the list here is this one. So we will use this. Okay. So this can be rewritten as 8 times integration e power of x dx. And if you see here, this part is actually the same as this one. Okay, so the integration of e power of x dx is itself e power of x. So this is equals to, okay, the constant remain there, and then multiply with e power of x plus c. Just that easy. Okay, the next one for question F, we have integration 7 over x dx, where this is equals to integration, 7, we factor out 7, integration 1 over x dx. And if we look from the given formula, this will be the formula that we are going to use. Okay, integration 1 over x dx is equals to ln modulus x plus c. You cannot, in this case, if you see, we cannot write this as x power of -1, and you cannot use the power rule formula, this one, x power of n. Sorry. You cannot use this formula. X power of n plus 1 over n plus 1 plus c. Okay, we cannot use this formula because this formula is only true when n not equals to 1. Sorry, n not equals to -1. Okay. In this case, if you rewrite 1 over x, then it is x power of -1. So that is why we don't use this formula. Okay. So in this case, I'll erase this first so that you won't get confused. So in this case, this is equals to 7. Since we know that integration 1 over x dx is ln modulus x plus c, so therefore 7 times ln modulus x plus c. All right. Next, okay, now we want to look at more challenging questions. But before that, let us go back to the lecture slide. Okay, so these are the basic properties of integral or integration. So whenever you have integration k times fx dx, it is equals to k times integration fx dx. So we have say this in our example just now when we look at this example where we factor out the 3, this one also here we factor out the constant 8, and this one too where we factor out the constant 7. And then we can also there is a basic another basic property for integration is the sum and difference rule. So whenever you have integration fx plus or minus gx with respect to x, then we can split it into 2 as what we have here. And then the next property is the linearity rule, where we can actually, the linearity rule is a combination of constant multiple rule and also sum and difference rule, okay? Where we can factor out the constant and then we can split the integration into 2. So let us look at this example. Even though the solution for these examples are given to you, I just want to discuss it because maybe some of you cannot really understand how actually we find the solution, because some of you you didn't take maths, and you maybe you already forgot what you have learned for SPM, or maybe for your diploma or CGL or whatever. So I'll show the solution for this. We will discuss the solution here. Okay, so let us look. Okay, so these are the questions. Okay, we'll look at question A. Okay, for question A, we have integration for x cubed, where this is equal to 4 times integration x cubed. Okay, integration x cubed is in the form of sorry, I want to erase this first because I want to put the formula here. Okay, we put the formula here. All right. So question A, we have integration for x cubed, where this is equal to 4 times integration x cubed. Sorry, I missed the dx. Where if you see integration x cubed dx, this is in the form of integration x power of n dx. So this is equal to 4 x power of 3 plus 1 based on the formula, the power rule formula, over 3 plus 1, where our n here is 3. So x power of 3 plus 1 over 3 plus 1 plus c, where this is equal to 4 x power of 4 over 4 plus c, where this is equal to x power of 4 plus c, because we can cancel out this 4. Okay. Next, question B. For question B, we have integration negative 7 cos x plus 3 over 2 x dx. Actually, we're supposed to have bracket here because we have plus here. Okay, if you have plus minus expressions, then we should put bracket. So please make correction for this. All right, so this is equal to, remember we have the sum and difference rule. So in this case, we can apply the sum and difference rule. And actually, we want to apply the linearity rule, where this is equal to -7 integration cos, I missed dx here, cos x plus, plus 3/2 integration x dx, where integration cos x, this one, you'll get the result is sine x plus c. So therefore, -7 integration cos x, oh, I'm really sorry, I missed it, this part. I'm supposed to have here cos x dx, because it stands alone there. So -7 remain there because it's just a constant there. And then the result of integration cos x dx is sine x. So -7 times sine x. Okay, we ignore first the plus c sign because we have another part of integration, which is 3/2 integration of x dx. So plus 3/2 x dx. In this case, we know that x is equal to x power of 1, where x power of 1 is x power of n. Therefore, we will use again this formula, the power rule, for integration of x power of 1 dx. So for this, we got x power of 1 plus 1 over 1 plus 1. Then we put plus c. Okay. So this is equal to -7 sine x. Or I discussed the question C. It's all right. No, I'm really sorry. This is supposed to be question C. Okay. -7 sine x. And then plus 3/2 times x squared over 2 plus c. Okay. And this can be rewritten as -7 sine x plus 3/4 x squared plus c. Okay. So this is the answer. Right, next question, C. Question B, we go back to question B, where question B, we have integration 1 plus x cubed minus 1 over x squared dx. 1 over x squared times x squared dx. Okay, in this case, what we have to do, we need to expand first the function, where this can be rewritten as, okay, what you have to do, you have to multiply 1 with x squared, so we get x squared. And then we multiply x cubed with x squared, and then we will multiply -1 over x squared with x squared. So you'll get, it is equal to integration x squared plus x power of 5 minus 1. Okay. As I said, because we have plus minus here, then we will put bracket here. Okay. So dx, where Now we can integrate this as usual. I don't want to split it up as what we have in the sum and difference rule. We just apply it directly here. We don't have to rewrite split like what we have done here, because I assume that you now understand the concept already, because this is easy, straightforward. So this is equals to x power of x squared is x power of n, where again we will use this power rule. So x power of n plus 1, in this case our n is 2, so x power of 2 plus 1 over 2 plus 1, and then x power of 5 also is in the form of x power of n. So again we will use the power rule formula. So x power of 5 plus 1 over 5 plus 1 minus, okay, this is a constant, so we will use this formula, integration of kx dx, sorry, integration of k dx, where in our example here we have k is negative 1, so negative x, integration of negative 1 will be negative x plus c. Okay. So what's next? We want to simplify this. So x cubed over 3 plus x power of 6 over 6 minus x plus c. Oops, sorry. X cubed over 3 plus x power of 6 over 6 minus x plus c. Okay, so this is the final answer for question B. Next, we want to look at question D. Okay. For question D, we have integration. I'll go to the next page so that it will be easy for you to refer. Okay, we have put it here, sorry. And then we have the question here. Okay. So for question D, we have integration negative 4 root x, not root x, square root x plus secant square x plus 5ex, e power of x dx. Okay, we should have bracket like this here, because we have plus here, this one. Because we have plus, then we should have bracket. Alright, so now this is equal, so if we apply the power rule, actually, if we apply the sum rule of integration, then this will be equal to, actually we want to apply all the basic properties of integration, where this can be rewritten as negative 4 integration of root x dx plus integration secant square x dx plus 5, okay, we factor out the constant, integration e power of x dx, where this is equal to, okay, because this is for the first term that we have here, it is square root x, and if you see from the table of integration, we don't really have the formula in the form of square root x. Okay, a function that we want to integrate, we don't really have square root x, so we need to rewrite this so that you will have one of these formula. So this can be rewritten as negative 4 integration x power of 1 over 2 dx. Okay, the next one, no problem, just rewrite back 8 plus 5 integration e power of x dx. So for the function that we have here, x power of 1 over 2, it is in the form of integration x power of n, where in this case, our n is 1 over 2. Therefore, we will use that formula, where this is equals to negative 4 x power of 1 over 2 plus 1 over 1 over 2 plus 1 plus, okay, integration secant square x dx. We have it here. So the result is tangent x, therefore plus tangent x plus, okay, 5 constant remain there. And then we have integration of e power of x, where we do have integration of e power of x here. So the result is also e power of x, so 5 times e power of x. And don't forget plus c. Okay. If you see at this level, we already we already performed the integration, so we need in the end of the result with a constant plus c there. So this is equal to negative 4 x power of 3 over 2 over 3 over 2 plus tangent x plus 5 e power of x plus c. And here, if you see, similar to our previous example, we have fraction in fraction. We don't want our final answer to have fraction in fraction. So we want to rewrite this as negative 4 times 2 over 3 x power of 3 over 2 plus tangent x plus 5 e power of x plus c, where this is equals to 8 over 3 x power of 3 over 2 plus tangent x plus 5 e power of x plus c. Oh, I guess I missed, sorry, x power of, oh, I missed the negative 4 here, sorry. So we should have negative 8 over 3 x power of 3 over 2 plus tangent x plus 5 e power of x plus c. So this is the final answer for question D. Okay, next, question E. I'll put into a new page. Here we want this formula. We also want to see the question. So for question E, we have integration 2x power of 5 plus secant x tangent x dx. Okay, here if you see we have plus signs, therefore we should have a bracket here. Okay. So we should have here plus. This one's supposed to be bracket here because we have the summation of terms. Okay, so this is equal to integrate. Oh, I forgot to mention just now, if you are good enough, then, sorry, I go back to our previous example. If you are good enough, you can jump your solution. Okay, from here, sorry, you can jump your solution from here straight, sorry, from here, no, sorry. You can jump your solution from here straight away to here. Okay, from here straight away to here. If you're good enough, no problem. But maybe you want to rewrite this first as x power of 1 over 2. But as I said, if you already good enough, then you can jump, no problem, because there is no mark for this and this. We will consider this one. Okay. All right, next, for question E, we have 2x power of 5. So x power of 5 is in the form of x power of n. So 2 times x power of 5 plus 1 over 5 plus 1. And then secant x tangent x is this one. Okay, where the result of the integral of secant x tangent x dx is secant x. So plus secant x plus c. Don't forget when you start the integration, then you must have plus c in the end of your answer. So here we have 2x power of 6 over 6 plus secant x plus c, where this is equal to x power of 6 over 3 plus secant x plus c. All right. Next, question F. For question F, we have integration negative 2x power of 6 plus 7x squared minus 4 over x cubed dx. Alright, this is equal to, we have to rewrite this first, because if not, then you cannot perform the integration. Then what we will do here is we will split the terms, the numerator. We will split from one expression here, to 3 different terms. So what we will have here is this is equals to integration negative 2x power of 6 over x cubed plus 7x squared over x cubed minus 4 over x cubed dx. Okay, we put bracket here because we have this plus and minus sign, where this is equal to, okay, now first, before we can integrate, we will simplify this first, where this is equals to integration negative 2 x power of 6 minus 3 is 3, so negative 2x cubed plus 7 x power of 2 minus 3 is negative 1, so 7 times x power of negative 1 minus 4x power of negative 3 dx. Okay, for the x cubed, we have x power of n. So integration of negative 2x cubed will be negative 2 x power of 3 plus 1 over 3 plus 1. And then for the next one, this one you have to be careful. Okay, maybe I should rewrite this first. Sorry, I'll redo this. We erase this part first. We rewrite it first, where this is equal to negative 2x cubed plus 7 over x minus 4x power of negative 3 dx. Okay, why I want to write 7x power of negative 1 equals to 7 over x? Because if you see, we cannot use this formula, integration x power of n dx equals to x power of n plus 1 over n plus 1 plus c. We cannot use this formula, because in order to use this formula, you must have x not equals to negative 1. But in this case, you have x power of, sorry, not x, n, it should be n. This is not x, it is n. Okay. In this case, our n is -1, therefore we cannot use this power rule formula. And the choice that we have is this one. Okay, here. 1 over x, because 7 over x is equals to 7 times 1 over x. Therefore, this is equals to negative 2x power of 3 plus 1. Okay, this one we want to use this formula. Over 3 plus 1 plus 7 ln modulus x minus 4x power of -3 plus 1 over -3 plus 1 plus c, where this is equals to -2x power of 4 over 4 plus 7 ln modulus x. And then we have minus, we get plus, yes, plus 4 over -2 x power of, this one over 2, I made a mistake here, 4 over 2, because I already have plus here, plus 4 over 2 x power of -2 plus c. And this can be simplified as negative x power of 4 over 2 plus 7 ln modulus x plus 2 x power of -2 can be rewritten as over x squared plus c. Alright, next we want to look at question. Okay, we choose again this one here and then the formula here. So question G. We have integration sine x plus cos x over 2 dx, where this is equal to, we can factor out 2 integration sine x plus cos x dx, where this is equal to 1 over 2. 1 over 2 is a constant, just remain it there. And then multiply with the result of integration sine x is negative cos x. So here times negative cos x. And the result of integration cos x is sine x. So plus sine x plus c. Okay, you can just remain the answer like this because we cannot simplify it anymore. Next, question H. We have integration x plus x plus 4 over x square dx. So what we have to do first is we need to expand this function x plus 4x square because it just the function is just squared, so it is possible for you to expand. But if you have the power is greater than 2, such as power of 3, power of 4, that is quite hard for you to differentiate. But for that case, we will discuss it later. But for this particular example, we just have the power is squared, so possible for us to expand easily. So we will expand this function first. So when we expand, what actually we do is x plus 4 over x times x plus 4 over x dx, where this is equal to, okay, x times x is x squared. Sorry, I missed the integration, x squared. And then x times 4 over x is plus 4. And then 4 over x times x is plus 4. And then 4 over x times 4 over x is plus 16 over x squared. Because we have plus 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 here, so we need bracket dx. So next we will rewrite this to simplify the function. So this is equal to integration x squared. 4 plus 4 is 8 plus 16 x power of negative 2 dx, where x squared is in the form of x power of n, where n is equals to 2 in this case. We want to use the power rule formula, where integration of x power of n dx, it is equals to x power of n plus 1 over n plus 1 plus c. Okay. We want to use this formula here. So it is equal to integration of x squared will be x power of 2 plus 1 over 2 plus 1 plus, okay, 8 is a constant. Remember, when we have integration k dx, it is equals to kx plus c. Okay, where this formula is actually above here, but I just rewrite it here because I don't want to scroll just now. Okay. So integration of 8, we get 8x. Sorry, we get 8x. Again here, 8x. And then plus 16x power of negative 2 is also in the form of integration of x power of n, where x power of negative 2 is equal to x power of n, where n is equal to negative 2 in this case. So 16 remain there because it's just a constant. X power of negative 2 plus 1 over negative 2 plus 1. And don't forget, in the end of your result of the antiderivative, you must have plus c. Okay, where it is equals to x cubed over 3 plus 8x minus negative 16, and then x power of negative 1. Okay. But, sorry, I forgot the c, plus c. But remember, as I said, in mathematics, usually we don't want to write our final answer in the form of negative power. Therefore, we will rewrite this as x cubed over 3 plus 8x minus 16 over x plus c. So this is the final answer for question H. Next. Question I. For question I, we have integration 3 plus 4 e power of x plus 2 over 5x dx. Okay, here you need to put bracket here like this because we have plus plus here. So this is equal to, okay, 3 is a constant, therefore we will use this formula, integration k dx equals to kx plus c, where our k here is 3. So integration of 3, we get 3x, and then plus 4. 4 is just a constant, it remains there. And then e power of x is this one. So integration of e power of x is itself. So 4 times e power of x plus, this is, for this part, we have 2, or actually what we have here is 2 over 5 times 1 over x. 2 over 5 is just a constant. So we will write here 2 over 5. And then because 1 over x is in this form, therefore, the result will be plus 2 over 5 times ln modulus x plus c. Alright, so this is the final answer for question I, okay, because we cannot simplify it anymore. Next, question J. For question J, we have integration 5 sine x plus 1 over e power of 2x dx. Okay, we need to put bracket here. This one is supposed to have bracket because we have plus there, 5 sine x plus, okay, 1 over e power of 2x. First, we will rewrite this equals to integration 5 sine x plus e power of negative 2x dx. Because if you don't rewrite like this, then you cannot really see the function in the form of basic formula of integration that we have here. Okay, so this is equal to, okay, the integration. I want to erase this one first. So the integration 5 sine x, 5 is a constant, just remain it there. Integration of sine x is negative cos x. So here we have negative 5 cos x and then plus. Okay, for this problem, you need to see from, let me check first. You need to see formula from, let me check first, okay? You need to check from page 23, where you have the formula is integration e power of kx dx. It is equals to e power of kx over k plus c. Okay, so for integration e power of negative 2x, because e power of negative 2x is not like this, it is like this because we have a constant k here where k is equals to negative 2. So the result for integration e power of negative 2x will be e power of negative 2x, e power of negative 2x over k, where k is negative 2, so plus c. So this is equal to negative 5 cos x minus, okay, remember for our final answer, we try to avoid negative power. So we will rewrite e power of negative 2x over negative 2, become negative 2, 1 over 2 e power of 2x plus c. Alright, so this is the answer for question J. Next. Okay, for next question, I want to take it from your tutorial 4. tutorial 4. Question number let us look from question number 1C. 1C. Let me check first whether the numbering is correct or not. Yes, we have question C. It is we want to find the integration of 1 over square root x dx. Okay. Where this can be rewritten, if you see from our formula here, we don't really have in the form of 1 over square root x. Okay. So what we have to do is we need to rewrite this so that it will be in the form of the one of the basic formula that we have in this table. So this can integration 1 over square root x dx can be rewritten as integration x power of negative 1 over 2 dx. And clearly this is in the form of integration of x power of n, where n in this case is negative 1 over 2. Sorry. Therefore, it is equal to x power of negative 1 over 2 plus 1 over negative 1 over 2 plus 1 plus c, where this is equal to x power of 1 over 2 over 1 over 2 plus c. And remember, your final answer, you shouldn't have fraction in fraction. So we will rewrite this term where this is equal to 2 times x power of 1, because maybe some of you cannot see, because when we have x power of 1 over 2 over 1 over 2, it is actually 2 over 1 times x power of 1 over 2. Okay, so plus c, where this is equal to 2x power of 1 over 2 plus c, and we can also rewrite this as 2 times square root x plus c. Okay, so this is the answer for question 1C of your tutorial 4. Next, we want to look at question E. Okay, I'll go to next page. Okay, for question from tutorial 4, you have question 1E. You have integration 2 over x plus 3 dx. And for this question, you need to refer the formula from page 23. Okay? Refer page 23 under topic integrals of basic functions, where you have the formula is integration 1, sorry, I'll rewrite this. You have integration 1 over ax plus b dx. It is equal to 1 over a ln modulus ax plus b plus c. Sorry, I should. Ln modulus ax plus b plus c. Okay, so if you see here, our question, integration 2 over x plus 3 dx, this is actually 2 times integration 1 over x plus 3 dx. Okay, and if you compare this with this, then we can see that our a is equals to 1, because x here, this is actually 1 times x, where a is equals to 1. Okay? B is 3 here, but we want to know here what is a. So therefore, we have this is equal to, this is equals to 2 ln 2 over, because 1 over a, 1 over 1 is 1, so we don't write it there. So ln ax plus b, our ax plus b is x plus 3, so ln modulus x plus 3 plus c. Okay, so this is our answer for question 1E from your tutorial 4. Okay, next we want to look at question 2C. Okay, for question 2C, we have integration 4 times square root x minus 3 over x squared dx. Okay, first of all, we need to rewrite this as it is equals to integration 4 x power of square root x is equals to x power of 1 over 2, and then over x squared minus 3 over x squared. We split the function into 2 parts. Okay, then we simplify this, so it is equals to 4 times x power of 1 over 2 minus 2 is negative 3 over 2 minus 3x power of negative 2 dx. Okay, so now each of these, if you see here, we have it in the form of integration x power of n dx. It is equals to x power of n plus 1 over n plus 1 plus c. So we can use this power rule formula. So we have here 4 x power of negative 3 over 2 plus 1 over negative 3 over 2 plus 1 minus 3x power of negative 2 plus 1 over negative 2 plus 1 plus c, where this is equal to 4 times x power of negative 1 over 2 over negative 1 over 2, and then minus minus we have plus 3 x power of negative 1 over 1, so 3x power of negative 1 plus c. And this is equal to, okay, remember we don't want our answer to be fraction in fraction, so we need to rewrite this in order to simplify it. So what we will have is 4 times negative 2 over 1, or 4 times negative 2, plus, remember we also want to avoid negative power in our final answer, so 3 times x power of negative 1 can be rewritten as 3 over x plus c, and this can be, sorry, I missed this part. The first term should be this one. It should be 4 times negative 2 x power of negative 1 over 2, and this is equal to negative 8. Remember, we don't want negative power in our answer, for our final answer. Therefore, we can rewrite it as negative 8 over x power of 1 over 2 plus 3 over x plus c. Or you can also rewrite it as negative 8 over square root x plus 3 over x plus c. Okay, so this is our final answer for question 2C. Okay, I guess that's all for topic 4.1, antiderivative, and also 4.2, indefinite integral. And again, I repeat, for indefinite integral, we don't have certain limits given in the integral problem. This part, when you write it, the integration symbol, we don't have limits there. So when we have that, it means that we have indefinite integral. Okay, in next chapter, in next topic, we will look at definite integral, where you will have limits for the integral. Okay, that's all. Thank you. Bye bye.